So let's look at how we subtract two vectors. Now, firstly, before we do that, remember we talked before about z and minus z, and the direction was opposite. Just going to show that using the idea that if we've got a vector z here, if we multiply it by I squared, which would mean that we'd multiply it by 90, and then move it by 90, rotate it anti-clockwise 90 degrees, and then rotate it again anti-clockwise 90 degrees, so pi radians or 180 degrees, we should get that same vector, but just pointing in the opposite direction, because that's what happens when you multiply something by I squared, and I squared is minus 1. So that's where we get the minus z from, but also we get that idea that we rotate. If you think about our modulus argument form that we did last week, when we multiply a complex number by 90 degrees, by I, it's a rotation of that complex number 90 degrees in the anti-clockwise direction. So it's just two movements of the anti-clockwise, 90 degrees and anti-clockwise. And so we get those two vectors there. So z and minus z. And that's important to realize where it is for the next part, because what we want to do is do z1 minus z2. So what we need to do, here's our technique. Firstly, we draw minus z2. Then we use what we did with the addition of vectors technique and show geometrically that we get this. So z1 plus minus z2 would be the same as z1 minus z2. Then we get our z1 minus z2 as a free vector, and we can move it round. So, and we want to actually take that z1 minus z2 as a fixed vector as such, but we can move it around and get that. So what we should get is a diagonal of a parallelogram. That is our aim again. So let's have a look. We've got z1, z2, as we said. Find minus z2, which will be opposite direction in terms of rotation of 180 degrees and same distance. What we want to do then is, okay, let's make it a free vector and do our addition. So z1 plus minus z2. So we get z1 there. We take our vector across and make it minus z2 to get to this point. So in that case there, z1 minus z2 would then be this vector here. So you can see that, and I've put in z1 there too, because you can see that z1 plus minus z2 would be the same as minus z2 plus z1. So we move it, we could put z1, move it down there, and we can see that it's going to get to that same point there. So that vector there is now z1 minus z2. So there's our vector. There's our vector there. So how does that relate back to our original vectors? Well, that's z1, z2. The vector here was z1 minus z2. So, and that's that free vector just be moved up. We can see that was the z1, that was z2 minus z2 there, and there's our free vector of z1 minus z2. It's been moved up to that. Now, if we have a look and complete our other sides of our parallelogram as we saw before, z1, z2, we did the addition to get that diagonal. There's our subtraction. There's our subtraction there is the other diagonal of that parallelogram. So z1 minus z2 is that vector there. Now notice z1 minus z2, the key here is which direction is it pointing in, which diagonal, which way does the diagonal go, because it could go the other way. So with the addition, it only goes in the one direction, but we've got the two here. So if it's z1 minus z2, the tip here is pointing to the z1. So the arrow is going to be at z1, so it's going to be in that direction. And we can show you z2 minus z1, and that would be what z2 minus z1 looks like. But how does that work? So we've got z2. What does z1 look like? Minus z1, well, that would be a vector looking like it's in that direction, so in a straight line. So if we make it a free vector and move it up, it's going to look at something like that. So it'd be minus z1 being moved up there, and again, then we get the vector that goes to that point would be Z2 minus Z1. So there's that fixed vector there, and now we take that one, shift it up. Okay, it's parallel, and it's same distance, so you can see that would be the diagonal of this parallelogram here, but going in this direction. So because it was Z2 minus Z1, the two arrows meet at the Z2 there. So there's our addition and subtraction using addition of vectors. We're able to do the subtraction of the vectors there. So have a look again. If you're not sure, have a look. It's not an easy concept to look and see how we get these ones. But remember, you can move these vectors around whichever way you like, and they're the same direction and they're the same size. They're parallel, so they're able to move around. You're able to get these nice parallelograms happening, and so the distances between the 2 points are going to stay the same.